very happy to see all of you here this morning. I hope you've had a great week at the conference. Yes? Excellent. It's always good when people nod without having to be prompted too much on that question. If you were at the party last night, I hope you enjoyed the dodgeball tournament as well. Were any of you on the winning team? All right, next year. Remember to sign up early. My name is Philip Heedy. I'm a product manager on the ArcGIS Enterprise team. And with me this morning, I have my colleague Whit Mateau from our professional services division. And between the two of us, we're going to spend the next hour or so talking about best practices for layers and service types. You've seen a lot of really cool things throughout this week. On Tuesday during the plenary, you saw Jeremy and his team show some really interesting new things you can do with the JavaScript API. How many of you were excited about that dot density renderer, right? Yeah. Yes. So now you want to know, how do I do that thing? And you're thinking, well, I just upgrade to that latest 4x version of the JavaScript API, right? There's always a little bit more to it. That's partly what we'll talk about here this morning. So we'll talk about the different service types that you have available with ArcGIS, both ArcGIS Online and ArcGIS Enterprise. And then we'll talk about some of the nuances and benefits that you get from each one of those different service types, what they can power within the platform and all of your great custom applications. So one of the reasons we do this presentation is that things have evolved over time. Things that were current or best practices 5 years ago may still work, but they may not necessarily be the best way of doing things anymore because other new service types and functionality has been added. So this is always a subject that changes over time. This presentation is current as of right now, and right now includes ArcGIS Enterprise 10.7, which is about to come out, as well as a lot of newer things that have come into ArcGIS Enterprise at the 10.6.1 level. So we'll highlight those things as we go along. Within ArcGIS Online, of course, there's very little you need to do because it just magically upgrades. So with that, I'll turn it over to Whit and let us get started.
Thanks, Philip. So we're going to pretty quickly dive into a lot of technical detail, which is, I'm sure, why you're all here. But before we do that, we wanted to set a little context as to what we're going to be talking about and why things are the way they are within the platform. So if we're going to step really far back and look conceptually at how ArcGIS Enterprise is implemented, we can think about it as being a system that connects users with data. We have lots of different data. Those might be stored in different places. Those could be in files like CSV files, file geodatabases. It could be in databases like Oracle SQL Server. It could be in data warehouses like Teradata and Netezza. It could be in blob stores. It could be in the cloud. Data can be stored all over the place. And we want to get that data to the user in a way that helps them do what they need to do, answer questions. So we have this bottom layer, which is storage. And there's different ways of storing data and different ways that data can be brought into ArcGIS. On top of that is functionality. So this is taking the data and using it to perform a function. That might be rendering a map or querying or performing some analytics. Now on top of the functionality is this idea of an information model, which takes the data and these different capabilities and puts them together in reusable information products that can be applied in multiple use cases for different types of users. And then on top of that is a user experience that takes this information product and provides tooling, an experience, be it web, mobile, desktop, for the user in a way that's meaningful for their job. So this is really conceptual, but you can think about what's going on in ArcGIS as having these 4 layers. Now in practice, the way that that's implemented in ArcGIS Enterprise is through data stores. This could be the ArcGIS data store, but it could be other types of data stores, like a registered folder or a registered database. The GIS servers, or ArcGIS server, is really what's providing that functionality, the mapping, the querying, the analytics, the geocoding. Portal is really the place where you create and manage these information products. And what we really mean here are web maps, web scenes, web layers. And it's the apps that provide the user experience on top of those information products through something like Web App Builder, a custom JavaScript app, Collector, or ArcGIS Pro. So if we just take an example, maybe we have a storm data set. That storm data set may be published through multiple services. So maybe we have a map or feature service that's exposing that data set for visualization and querying, as well as a geoprocessing service that does some analytics against that storm data. On top of that, we have a storm map that presents that as a layer with pop-ups, with symbology, potentially with filtering, time awareness, and things like that. And then that's exposed through one or more applications, potentially along with my geoprocessing service. So we have these different layers, and if you've ever wondered why we have this data store, server, and portal sort of separated, they perform these different functions. And we'll see in a minute that we'll be looking really at this middle swath of services and information products in this session. So a lot of what I think we'll try to convey in this session is you have a lot of different options at your disposal for how to publish data as services, as content within your portal. How do you know that you're doing it the right way? Or what's a strategy to decide how best to do that for your users? And that's really the objective of this session. And we are going to get into a lot of that at a technical level. But I would keep these things in the back of your mind as you're thinking about how to do that publishing. These are sort of like your functional and non-functional requirements for the use of that data. That will include who's going to be using it, how capable are they, do they need advanced tools, are they more basic users, are they on a mobile device, are they on a web browser, what are the capabilities they need within their use case, and then a bunch of non-functional things like performance. We always want a very performant map, but sometimes performance matters more than others. And a really high-performing map may come with some compromises. And then how much is it going to scale? Is this just for internal use, or is this going out to the public? And security and things like that. So these are some of the things to be keeping in mind as you're thinking about how to publish content for your users. Just a couple examples. You can imagine these being two very different use cases. So in the event of an emergency or disaster response, it's often common to provide an outage map for electrical and other utilities. These are maps that go out to the public and they're used by millions and millions of people a day. But they're very simple, right? They're just providing some information to the user in a one-way fashion. That's very different from this other use case, which is an internal facing. So it's just for your organization's stakeholders that are going out into the field, taking data offline, collecting data, and synchronizing it back. Those are two very different use cases, and they have two very different publication strategies for how you want to publish that content. So it's just an example. You can see how this can vary. So as we go through this, the approach that we like to keep in mind as we're thinking about how to publish content is we always focus on the business, focus on the users. What is it that the end users really need? Once we have a handle on that, then we go back and we look at our data and we see where is it being stored, what format is it in, et cetera. And then we can work upwards. From that, I can publish these kinds of services. I can make it available in the portal through these types of layers and maps, and then these applications. So you sort of start at the top, then you look at your data and work up towards the application. And I think it's important to keep in mind that this is a rapidly changing field, as Philip said. On top of that, the technology is changing, but also your users' needs are going to change. We've sort of passed the point where you can study a problem, build an application, you know it's going to target these 100 users for the next 3 years. The system and this WebGIS pattern is very agile. Users are going to be coming in, they're going to be doing new things, you'll have new use cases, so it's always important to be reevaluating how you publish data and make that available to users. Oh, sorry.
All right, so now that we have that in the back of our minds, and keep that in the back of your mind as we keep going throughout this session, I want to get us started on that technical foundation before handing it back over to Whit and looking at the specific details of what we're talking about here. If we go back to what Whit was just showing us with these conceptual components, you have those 4 layers, you have the different pieces that make it up within the ArcGIS platform and ArcGIS Enterprise specifically. But we're going to be focusing on those 2 pieces in the middle for the most part, right? We're going to be talking about the services at that GIS server tier, map services, feature services, vector tile services, all those different types of things, as well as the layers that go on top of them from within the portal, the map image layers, the feature layers, where you can do a lot of configuration as well. So that's where we will focus the meat of this session for the rest of our 50 minutes together. When we're talking about the technical foundation, the first step, once you've identified your needs and the data, is to actually publish that data out as one of these types of services. So when we talk about publication clients, today there's really two different clients that we're looking at. ArcMap has been with us for a long time, supports many of these different service types, but ArcGIS Pro has been around for several years now and introduced several new capabilities that it's important to keep in mind. So when we're talking about the different service types and the layers, we'll also point out where there's something to keep in mind with regards to publication clients themselves. Another key concept is the difference between what we call hosted services and what we, for lack of a better term, refer to as more traditional service types. Hosted services is where you hand over a copy of the data to the ArcGIS system. A user may, as part of your application, hand over a CSV file, upload a CSV file and want to map that. That typically turns into a hosted service because now we manage the data within the system itself. Traditional services reference data in place. Those attached data stores that Whit was talking about. You have your data in SQL Server, in Oracle. When you publish that data out, we're not yanking a copy, a snapshot out. We simply reference it in place. So whenever you make updates to that data, a live copy is always being referenced by the system. So that's a key distinction between hosted and traditional services. And then remember those different data stores that Whit also mentioned. There's a correlation between hosted services and traditional services and the underlying data stores. The ArcGIS data store is a specific component of ArcGIS Enterprise which powers those hosted services. Where does that data actually go when you hand over a CSV file? Well, it gets stored somewhere, and that somewhere is ArcGIS data store. In ArcGIS Online, there's a similar concept, but it's more hidden from you because it's a managed system entirely. Registered data stores have a lot more variability. It's those registered file shares with file geodatabases, CSVs, shapefiles. Shapefiles? Yes. Do you have your I Heart Shape sticker? It can also be those registered databases. Again, SQL Server, Oracle, and so forth. Sometimes they may be geodatabases, sometimes they may be simply plain spatially enabled databases. And then more recently, over the last several years, we've added support for registered cloud stores for certain types of operations. So there's lots of different things going on here. So now when we look at the key concepts that we'll go into much more detail on is the distinction between features and map images. Traditionally, map services produce an image of something. It's not an interactive thing. It's just a JPEG or a PNG being returned back to a client. You can draw some very advanced things using that kind of methodology, but it's not something you can actually click on and interact with directly in a client without doing a whole lot more work. On the other side of that are features, actually getting the geometry, the attributes down onto the client itself so you can do very highly interactive things. Keep those two differences in mind as well as we're talking about the different service types that we have available. Then there's tiles, caching, and generalization. So let's go into those four things a little bit. It's really important to think about what's going on when you make a request from an application to the server to do something. If it's a query or draw me a map, something. What gets sent to the server and what gets sent back from the server. For those map images, the request that goes to the server is please draw me a map at this extent, this resolution, and then the server returns a JPEG or a PNG. Whereas if you're performing a query, it is within this extent, with this definition expression, a where clause, please return me the features that match. And what gets returned back is typically JSON, or as we'll see, some other newer formats in some cases. So that's a very different request and response behavior between the two different things. One is server-side rendered. The server is doing the work to create an image. The other, the data is returned down to the client, and you can do these very advanced things within the client these days. And this is where there's a big difference between what was possible a number of years ago versus what is possible today. That dot density render that you saw in the plenary, well, that was all client-side rendering. We would have killed for that 10 years ago. Now it's here. We're very excited. We were just talking about this before the session. That's pretty cool. But that relies on the client being able to get the right amount of data really quickly to be able to do all those great things within the browser. So we'll talk about what those things are under the hood. When we talk about tiles, there's this idea of tiling that we've used for years in the context of cached map services. Instead of saying, please draw me a map, and the server doing some work and then returning a map, the server has pre-rendered a lot of maps in the case of raster tiles. This is what we call those traditional cached map services. But there's new types of tiling formats as well, so vector tiles also uses this concept and is a slightly newer thing. The benefits of tiling is that you can make parallel queries. You can request multiple tiles all at once. You can start downloading a whole lot of data, make use of all that bandwidth if you have it available. Caching is that idea of pre-generating the data. Instead of creating the response just in time in response to a request, it's already sitting there just waiting to be streamed back, typically really, really quickly. So when we look at caching, it gets kind of interesting. Often we've used the term caching to talk about things that were pre-rendered on the server side, sitting, waiting to be served back. But today it's also important to keep in mind things like client-side caching, especially in the case of browsers. They have the ability to store a lot of data in memory, and if you're smart about how you use that functionality, you can get even higher performing apps. Then we get to this idea of generalization. Very often, you have really highly detailed data sitting on the server. But it's not always that we need that full high-res geometry actually sent down to the client if we're doing things like visualization. If you're zoomed out to the extent of the entire world, do you really need to see every single little vertex on the coastline of California? Odds are good that you don't, right? Because the resolution of the display you're looking on doesn't even allow you to see all those little vertices. So there's lots of different ways that we use generalization within the software today. And you, when you're building your custom applications, also need to keep this in mind so that you're not publishing things you don't need to, or you're generalizing on the fly. And we'll talk about how we're doing that within some of these newer service types as well. So keep those concepts in the back of your mind, and let's dig into some of the services.
So as a lot of you know, I'm sure, ArcGIS Enterprise, ArcGIS Server, can support lots of different service types. In this session, we're really going to be looking at the service types that we're probably all using, which is two-dimensional visualization and mapping services, and that includes these four. And so these are the four we're going to spend a lot of time on today. Map services, both dynamic map services and tiled map services, vector tile services, and feature services. But it is important to keep in mind there's other types of services even for visualization. There's image services, which are used to visualize and analyze raster data. Scene services, which power this scene viewer and 3D visualization. And then stream services, which stream data using things like WebSockets from GeoEvent, providing real-time data. And on top of that, there's a slew of other services that do things other than mapping and visualization for things like analytics and geocoding and some more specialized services. So that's just a little bit of context. We're going to focus on those four on the top left. So let's dive in, and we'll be applying some of the concepts that Philip talked about. So a dynamic map service. How many folks remember MapQuest? All right, still a large portion, okay. So this is, if you go way back, this is how internet mapping began. It was the idea that, because the browser technology wasn't very good. Our networks were slow, and the best way to get a map onto my web browser was to render it on the server and send it back as an image. This is how ArcIMS worked, and we still support this and use this very much in technology today. So the client sends the extent, the image size, the format, which could be PNG or JPEG. It's an image format, and it returns a map image. So this is what powers, if you look in ArcGIS Enterprise or ArcGIS Online, you'll see this thing, the map image layer. Dynamic map services power the map image layer. This is only supported in ArcGIS Enterprise today. This is not a type of service that you can publish in ArcGIS Online. And this works on what we call user-managed data. So this is not a hosted service, it's a traditional service, and it works against the data that you manage and register with the server, not data managed by ArcGIS. So some of the key capabilities, this does do rendering on the server side. It does still support dynamic layers and rendering. So even though it's returning an image, you can send in different rendering instructions and it will render it differently per your instructions on the server. And even though it's returning an image, it does support identify and query. But because the browser doesn't have any of the data, or the client, it just has an image, if you identify or query, it has to go back to the server to answer that question and bring that back. And this does support a number of OGC standards for those of you that are needing to provide OGC support, like WMS, for example. So this was the original one in a lot of ways. It is still being used today. I would say we're shifting away from this towards other service types that we're going to talk about. But this is still useful in a number of cases. Typically when you have a lot of data, you have a need to really visualize, for whatever reason, like hundreds of thousands of features. Or you may be on constrained networks and you really can't afford to be sending data to the client. You need to be sending a very small payload.
I think that comment about the dynamic layers and rendering is really important because we have a tendency to think about dynamic map services as being fixed in time. Whatever you authored within ArcMap or Pro, that is the image you'll get back. But that ability to actually turn layers on and off dynamically as part of your request and even change the symbology is very underutilized. So I think that's something to keep in mind. I want to point that out.
Yeah, thanks, Phil. So next up is, this is also sort of chronological in a way, at least so far. So next came tiled map services. So this is, if you publish this to ArcGIS Enterprise, it's still a map service. But when you publish a map service, you have the option of turning on caching, tile caching. And when you do that, it starts to behave differently. Instead of passing it in these instructions to render me a very specific image per my request, all of those images are essentially pre-generated and sitting on the server. And all I'm doing is I'm saying, give me the tile at this level of detail with this column and this row, and it streams back a little 256 by 256 pixel image, and my browser is making lots of those requests, and it builds up that map very quickly. This is really when Esri and Google and others started making available base maps some 10, 12 years ago. This is how all of the base maps were, and many of them are still using this technology today. So some of the capabilities, so this is what powers the tiled layer in your portal or in ArcGIS Online. This is supported in ArcGIS Online and ArcGIS Enterprise as a service type. And this can work against both user-managed data as well as ArcGIS managed data. So you can point ArcGIS server to one of your databases and have it generate a tiled map service and cache tiles, or you can publish a hosted service and choose to have that be a hosted tile layer, in which case ArcGIS is managing that. So you have both of those options. This is all rendered on the server. It's just essentially a dumb image that's being passed back to the client. This does cache using tiles, so it takes advantage of some of the benefits that Philip talked about, which is not just that it's pre-rendered on the server, but also it can be cached in the browser. This type of service does allow users to take data offline. So it can generate a map package, a tiled map package, that a user can take and run on a mobile device and work without internet connection. That's not something that a dynamic map service can do. And this also supports an OGC standard like WMTS. So this is really the proven solution for complex data that's relatively static, that's not changing a lot. It's almost ubiquitous as base maps, and it's extremely high performing. So when you have to put data and content out to millions of users in something like an outage map, this might be something to think about. Because all it requires is essentially a web server type capability to serve up images. It's really light on the CPU and memory. That brings us to vector tile services, which is the newest one of the bunch. Vector tile services were released 3 years ago, something like that? Something around 3 years ago. This is also powering the tiled layer in your portal. And it works logically the same way. The client is sending a number of get tile requests with a specific level, row, and column. But what's coming back isn't an image. What's coming back is actual data. Now, that data is in something called PBF format, which is protocol buffer, which you can think of as a optimized binary package that's easy to create on the server and easy to deserialize in JavaScript. So it's a very handy protocol for exchanging data from server to client. And so then the client gets that. It now actually has vector data in the client, which means that it's doing the rendering on the client. Now this is supported in both ArcGIS Online and ArcGIS Enterprise. This is ArcGIS managed data only. Now, the way that this would work is you can connect Pro to your data, but when you publish a vector tile service, it's essentially creating that vector tile package, giving it to ArcGIS Enterprise. ArcGIS Enterprise then manages that. So it doesn't have a live connection to your data. The rendering of this is all done client side. This does do caching using tiles. The tiles have to be pre-created. You can't do caching on demand. One thing to keep in mind is this does pre-generalize the features, which makes this really, really fast to create. I can't remember the exact numbers, but our team at Esri creates worldwide base maps for both map tiles as well as vector tiles. The map tiles take a week or two on an array of servers and ends up being in the many terabytes. We can do the same thing with vector tiles on a laptop in less than, basically overnight, and it's in the gigabyte range.
Yeah, and a more down-to-earth example for those of you who don't necessarily deal with global data. I've done a demo a couple of years ago caching the entirety of the country of New Zealand. Which pretty decent area, not gigantic, but also not trivial. We're not talking city-sized. Took a minute. I did it in real time on my laptop of 3 years ago. Took just over a minute and created a 29 megabyte vector tile package. Mm-hmm. That's not even funny when you compare it to doing it the old-fashioned way.
Yeah, it's much different. Part of the reason that it does that so quickly is it does pre-generalize the features as part of the vector tile creation process. It also clips features to tiles. So if you actually have a stream or a street, it's going to get cut into different tiles. That makes it very good for visualization. It makes it not so good for querying and analysis because we don't have basically the complete integrity of our features anymore. So we don't support query and identify and analysis against vector tiles. It's for visualization only. But one of the key benefits, aside from being a great base map, is that you can take it offline. But unlike map tile packages, these are really, really small. So you can get basically the whole country's base map on a cell phone now and take that offline without any connection to the internet, which is pretty neat. So with that, let's see. Oh, yeah, one other thing to keep in mind. There's a concept called over-zooming. So this is another reason why vector tile packages are quite smaller. It may be kind of hard to see in the back, I'm not sure, but you can see there's sort of a grid here over this map of San Diego. And what you'll notice is that the grid isn't uniform in cell size. Where there's more data, there's more tiles. And so what that basically means is when creating vector tile packages, we don't create tons of tiles over the ocean, because it's actually vector data, which means that if we did this with map tiles and you zoomed in, your pixels would be stretching. It would look terrible. But because we have vector data on the client, as you zoom in, if we don't really need higher fidelity features, more vertices on our geometries, we can actually render that we don't stretch and pixelate, right? We have the vector data, so we can over zoom and use that same vector data to render a good looking map. And for that reason, when we create the vector tile packages, we do it in a smart way. We create this index. So where there's not a lot of data, we don't actually create tiles. So another reason why it's more efficient.
Yeah.
So let's see here. I think we're going to switch over to a quick demo. Yep.
Let Whit type his password before I switch over.
All right. All right, thanks.
There you go.
So here we just have the default map in my map viewer. And if I switch to a different base map, let's switch over to the dark gray canvas, and let's bring up developer tools. As I zoom in, you can see here, these are all PNGs and JPEGs. So if I can kind of look around, there's the JPEG for the tile right here. And then if I scroll down, we also have PNGs with a transparent background for the labels. So it's basically just streaming these images, right? This is the map, the tiled map service. Now, we do make vector tiles available. The way that you can expose that in your organization is to go to your organization settings under map. And there's a little box here you can check that says use Esri vector base maps in supported ArcGIS apps. Now, the reason we have that in supported ArcGIS apps is not all clients are capable of supporting vector tiles. These days, I think most of them are. So I'm going to check that, and I'm going to save the map. Now let's switch back to my map. Let's create a new map. And now I can switch over to the dark gray canvas. And zoom in a little bit. You can see it looks and feels pretty much the same. But if I see what comes back here, I'm now getting these PBF files. That's the protocol buffer. And if I click on them, it's binary, right? It doesn't make any sense. But it is a nice, efficient format of delivering those same tiles in a sense that I was seeing in the map image, but as vector data, and then it gets rendered on the client. Now, one of the benefits of vector tiles over map tiles is that you can actually change the symbology, which means that you, in your organization, if you don't like this black-gray canvas map, you want to spruce it up a little bit, you can do that. And so you can do that using the vector tile style editor. So I'm just going to get started with the dark gray canvas. And you can see that I get a few different views here. I'm not going to go through this in detail because it was shown on Tuesday, and this is something that's available. You guys can get in there and explore. But just to kind of give you an idea, I'm going to use the quick editor. I'm going to change the color of roads, maybe to something like that, and you can see the roads in my vector base map have changed. And maybe I'm going to change the water to like a dark blue, something like that. I want the labels to be a little bit higher contrast now, so I'm going to change the contrast, and then I'm going to make my labels a little bit bigger. This is, nothing that you could ever do with the map tiles, right? Because those were cooked into the images. But here, because it's vector data, I can do this. And now I can save my map. We'll call this my canvas base map. All right, and now if I come back in here, let's just search for my content. I've got my canvas base map, and I'm going to use that as my base map in here. And now I have the map that I just created. I can use it in my map, and if I want, I can share this with the rest of the organization and even have it show up here in the base map dropdown by working with the settings of my organization. So it gives you a little idea, I think, hopefully, of the difference between map tile and vector tile, and some of the newer capabilities with the style editor to actually create your own base maps without having to work with any of the base map data. You just change it on the visualization side. Yeah. All right. So last but definitely not least is feature service. So Philip talked a little bit about what it means to be getting features back instead of map images. You can think of this as the browser or the client is sending essentially a spatial query to the server, and it's then returning the data along with the geometry back to the client so the client can render it. But one of the things that's different is it's actually not typical that the client application sends one request to the server for every map. It actually splits it up into multiple requests. And it actually uses the same tiling scheme. So tiling scheme is essentially that three-dimensional grid that makes up how, with vector or map tiles, you organize your base map. And there's a standard tiling scheme that just about everybody uses. Well, feature services and clients like the JavaScript API actually use that same tiling scheme when requesting feature data from feature services. So it actually will send out somewhere between 5 and 20 feature requests, depending on your scale and area, and it will get all that back. And so that includes some of the benefits that Philip talked about in tiling. That means we can parallelize the requests, and we can do caching. So we can actually cache feature data on the client.
That's a really good example of something that's changed over time, right? This is a feature of some of the newer versions, and I'm not sure exactly how far back this goes these days, but maybe within the last couple of years, within the JavaScript API. If you go back to older versions of the 3x or even past versions of the JavaScript API, traditionally they sent a single big query and got a gigantic amount of information potentially. Now it sends many smaller queries and gets data streamed in parallel.
It's worth noting that feature services have been around for a long time, but there's been a series of advancements. That's one, we'll talk about a couple others, that have made it such that feature services are now a very viable option for a lot of data that you would want to visualize and work with in browsers and other mobile clients. So we often refer to this as feature tiling, which can be a little bit complicated or confusing when we also have vector tiles. Vector tiles is a formal specification that's out there. Esri is not the only organization providing vector tiles. So when we talk about vector tiles, it means a specific thing. It's these protocol buffers that are being returned with features that are generalized and clipped. Feature tiles are different. This is essentially a feature service that's returning data in tiles as opposed to all-in-one. So feature services power the feature layer and table item types or layer types in your portal or ArcGIS Online. The difference is if it doesn't have a geometry column, we call it a table. If it has a geometry column, we call it a feature layer. These are supported in both ArcGIS Online and ArcGIS Enterprise. This can work with both user-managed data that you manage and register with ArcGIS Enterprise, as well as ArcGIS managed data. So you can publish hosted feature services to both ArcGIS Enterprise and ArcGIS Online. So some of the key capabilities, we talked about, this does do rendering on the client. What's coming back from the server is just the data. The server can provide default rendering instructions. So when you publish a feature service, you do include a renderer with it, but that renderer is given as information to the client application so that it has some default style to use. But then your application can change that style. This does support identify and query, and as we'll see in a moment, we can even do more analytical style stuff with the data once it's in the browser. This does support generalization on demand. There's a specific type of generalization that's relatively new. We've had the classic generalization in there for some time, but there's a new one in there called quantization that's really kind of supercharging the modern feature service. Feature services are editable. This is actually the only service type we've looked at so far that also supports editing. You can take the data offline, both as a package, or you can actually synchronize data, two-way sync. So feature service is really what powers field editing applications in things like Collector and Survey 123. And this does also support OGC standards like KML and WFS. So I would say that feature services have really emerged as the new standard for your operational data. If you don't have a need to visualize more than 25, 50,000 features, and your data is changing very often, feature services really are a great option. So to give you a little idea of how things have changed and what you can do with feature services now, I'm going to switch over to a demo. So here we're looking at a map of counties in the United States. I'm zoomed in here to Palm Springs. What I want to show you is how this performs as I zoom out and add more and more data. So to do that, I'm just going to turn on my developer tools, and we're going to start zooming out. You can see the maps performing quite well. The counties are loading just about as fast as my underlying base map tiles. Still good. Still good. Okay, now things are getting a little bit slower. You know what? Let me do this in incognito mode. I think this was all cached on the browser.
You're cheating.
I know, this is the wrong demo to cheat on. Okay. All right. Okay, so it's starting to get a little slow and loading. You can see that I've already loaded 5 megabytes of data into my browser, and I'm not even looking at the full US yet. Okay. There it's going. It's been more than 30 seconds. 7.98. Okay, so this is what feature services looked and felt like not all that long ago. It's not using WebGL on the client side for rendering, and it's not using feature tiling and this new feature we call quantization on the back end to really optimize the data that's being sent back. So it did load. That took almost a minute. You can see some of these requests, and it loaded about 17 megabytes into my browser. Not a very practical application, right? Now, let me take the modern feature service, which uses feature tiling, WebGL, and quantization. And I'll show you what I mean by quantization in a minute. Start zooming out. Keep going. Data is still loading fast. There we go. I loaded the whole US. As I zoomed out, the data came back almost as fast as the underlying base map tiles, and I just loaded 364K instead of 17.5 megabytes. So that's a pretty big difference. So the reason, and on top of that, my map is fast and interactive because I don't have a lot of data sitting in the browser. Where this feature layer, it's kind of hard, to get this impression maybe in the audience, but you can just, it feels like it's holding my mouse back. It's just slow. It's really putting the browser to work. Where the new feature service here is fast and snappy and slippy. So the reason this works, we have WebGL on the client, which I'm sure you've heard about over the course of the week. What's happening on the server, if I click on one of these requests and look at the geometries, this is one of the polygons that came back. It's a ring, okay? So that's a polygon. But there's a few things you'll notice about it. First, I'm not actually looking at Web Mercator full fidelity, 15 character coordinates, right? I'm looking at small numbers that are integers. So the one thing that's happening is What's really happening on the server is the client application passes it some information about what I'm viewing, my view frame, and on the server it maps real-world coordinates onto a virtual space that's much smaller and more efficient. Basically, it's not giving me data that I don't need, right? You can think of it as turning real-world coordinates into pixel coordinates on the server. That's not actually what it's doing, but I think it's a useful model to be thinking about. Don't give me more information than I need to actually render the map. So that's one thing. Second thing is, as it does that, as it takes real-world coordinates and puts it onto the virtual space, it removes coordinates that it doesn't need. Those could be coordinates that are essentially on the same place in that virtual space, or even things that are collinear. If I've got a line from here to here and there's a vertex in the middle, I don't need that vertex. It's the same line regardless of whether or not that vertex is there. And then the third thing that it does, you'll see that my first coordinate here is an absolute number, 8 and 128. Everything after that is incremental deltas. Up, right 0, down 4, right 4, down 0, right 0, up 6, that kind of thing. You can think of it as it's storing coordinates as like you're drawing it with a pen, not absolute for each one. So all of that results in a very small payload size. Small payload size coupled with new technology on the client to do WebGL style rendering, and this thing really does perform quite well.
So this is quite the game changer, isn't it?
Yeah, I think so.
What do we need to make this happen? What do people in the audience have to do?
You need 10.6.1.
Oh, how many of you have upgraded? Did you upgrade because of this? Did you even know it was there? Did you realize what had happened after you upgraded and it just magically lit up? Mm-hmm. So there's two things you need to do. You need to, if you're using ArcGIS Enterprise, you need to upgrade to 10.6.1. For those of you who haven't done that, here's your business case for going back and saying you need to do it. And then you need to use a semi-recent version of the JavaScript API, both 3x or 4x. One of the really nice things about this is it is supported on any type of feature layer, meaning whether it's a hosted feature layer, it was a feature service you published from Pro, a feature service you published from ArcMap. All of them support this. You don't have to do anything special. You don't need to republish any old feature services you had. It comes along for the ride. And then once you upgrade your applications to use a newer version of the JavaScript API that knows about this, it just happens. Mm-hmm.
Yeah. If you do this in ArcGIS Online, this feature was available in ArcGIS Online a little bit before 10.6.1. And if you go and do this now, you'll actually see what ArcGIS Online returns. Here I'm looking at JSON. ArcGIS Online will return PBF. So ArcGIS Online now supports, in addition to a JSON response format, the protocol buffer format, which is even more efficient and compressed in terms of getting data from the server to the client. That's not yet in ArcGIS Enterprise, but keep an eye out on that. That will be coming at some point in the future.
Right, so we went from 17 megabytes worth of data being downloaded to 300 and some kilobytes.
360K, yeah.
PBF pushes that even further down to something slightly smaller yet again. You'll see a few things starting to use protocol buffers with the ArcGIS Enterprise 10.7. Not every single variant, but it's really seamless. You don't even have to know that that's going on under the hood. The JavaScript API, if it's a version that knows about PBF and it recognizes that the service supports it, it just does it in the background. It's not even something you turn on as a developer. It just happens.
Mm-hmm. And one of the nice things, in addition to it being fast, is we have that data on the client. And so the JavaScript API and other technologies have evolved so that we can actually do more with that data once it's on the client. So
that's a good point, by the way. It's not just the JavaScript API. We keep using that as an example because that's one of the places where there's just this very noticeable effect right off the bat. But clients like ArcGIS Pro also knows about quantization. So when they're interacting with feature services from ArcGIS Online or Enterprise 10.6.1 and higher, we'll also make these quantization and PBF requests.
Mm-hmm. Yep. So this is a simple application showing homicides in the Chicago area. So I can click on these, and it does a little buffered query. Okay, that's cool, but we've been able to do that for a while, right? That goes back to the server. But I can click on this, and I can drag it around. And you can see everything and my charts and everything updating in real time. It's not going back to the server. It's doing all that querying on the client. So this opens up new opportunities to do even more in your applications, faster and more interactive, all in the client when you're using feature services and you have the representation of the data on the client. Where vector tiles, you can't really do this, at least not in the same way, because it's all clipped up and generalized. Here, it is somewhat generalized because of quantization, but it still gives me enough fidelity in the data for me to be able to do my querying and analytics here on the client side. So it's pretty powerful.
Very cool.
Yeah. So one last thing before we sort of switch onto, we focus a lot on ArcGIS Server and the services. We want to talk a little bit about what you can do in the portal with web maps, web layers, and web scenes. But before we do that, there's one other nuance here that often gets overlooked, and I know I overlooked it for a while, and I think it's important to talk about. So when we talk about feature services. Feature services are a very specific type of service that you publish. If you're publishing a traditional feature service, so not a hosted feature service, it actually needs to be an enterprise geodatabase. But if you're publishing a hosted service, you put your data into ArcGIS Enterprise, it'll put it in the data store and make it available. But that's something, if you look at the URL, it's / feature server. And that supports specific capabilities like editing and sync. Sync is for taking data offline. But there is another way to get feature service-like capability in your maps and applications. So the other distinction is feature layer. So when we talk about feature layer, we're referring to the layer type in Portal. And a feature layer is also what's used in the JavaScript API to provide a lot of these, interactive capabilities. So typically, when we think of feature layers in applications, we think about that connecting to a feature service, either to the entire service, which may contain multiple layers, or to a specific layer within that service. And if you're familiar with the URLs, going to a specific layer would be / feature server / 0, 1, 2, whatever the layer ID was. But there's another way to get feature layer capability, and that's to use map services. So if you publish a dynamic map service, and you go to your portal, or you could do this straight in the JavaScript API, but if you do this in your portal, you can add a URL to a layer in a map service. So instead of giving it the full URL / map server, you give it the full URL / map server / layer ID. And when you do that, it actually shows up as a feature layer item in the portal as opposed to a map layer item. Because these feature layers in a map service support the query operation, which is really what powers the feature layer capability that we just showed. So that's like a long way of saying, if you really need this feature layer capability, and it's for whatever reason, it doesn't make sense for you to publish feature services, or maybe sometimes you actually need a map service, you can actually get that capability off of your map service directly by just pointing at the layer, either directly in the JavaScript API or as you're creating that layer item in the portal.
And it's truly something that we've seen over the years trip many people up. I've had this conversation with a lot of people that said, well, I can't use feature layers and all these cool client-side things because I can't publish my data with feature access enabled, because to do feature access, it needs to be an enterprise geodatabase. I only have a flat file, a file geodatabase. You can publish a map service and still do everything that Whit just showed you. You simply point to the /0 or the /1 / whatever layer under that map service, and it behaves like that read-only feature service, if you want to think about it that way.
Yep. So it supports the visualization and the querying. It does not, if you're using a map service and you're using it in this fashion, you cannot edit it and you cannot take it offline with a sync. Those are two things specifically that require the feature service.
All right, we've shown you a lot of really cool stuff with the demos, and we dwelled a little bit more on the technical stuff than what we've done in some other versions of this presentation, because you guys like the developer tools, right? It's the Dev Summit. We've got to show you that query with the PBF going on behind the scenes. So I do want to touch on a few higher level concepts again as we're trying to round out the session. So when we talk about the different service types, the layers, what we were just talking about now with the distinction between a feature service and a feature layer. The feature service is the REST endpoint that comes out of the server itself, and the feature layer is the thing that you're creating within your client application. Take that and think in terms of the overall geo-information model within ArcGIS. We've got these higher level concepts. For many years, we talked almost exclusively in terms of services. And you stitch together those services within your applications. Now, more recently, well, getting to be a long time actually, but still, we keep having this conversation. We introduced these higher level concepts, web layers. So a feature layer, a map image layer, and then we put these together as part of web maps that are collections of those different types of layers, right? So in practice, when you go into ArcGIS Online or the Enterprise portal and construct one of these web maps, you're defining a set of map properties, you're adding different types of layers, including your base maps, and those layers can themselves have different types of configuration information associated with them. If you want to override that default renderer that came from the feature service on your feature layer within the web map, you can specify a different type of rendering. There's lots of really powerful things you can do when you start thinking about this. So you take your web map, you add your web layers, and when you start using that web map within your applications, you don't have to do all of the configuration in code. Your application doesn't have to know how to put these things together because it's essentially reading a configuration JSON, that web map, from the portal itself. So the first thing your client will do when you follow that pattern is to get that configuration, the web map, and then it makes many requests to those underlying services, the layers specified within the web map itself. Now, where that becomes really useful is when you start thinking about your data. Go back all the way to the beginning of the presentation when we talked about the data storage, the services, now the layers on top. For many years, it was really common to see the pattern where we had one data set sitting in a database somewhere. And then we published multiple different versions of that data set to different services. And then we created individual web layers out of each one of those services. This is how we've done things for a long time, and it's a very viable pattern for many things. But you can start thinking about it in slightly different ways as well. You may not necessarily need to publish all those individual services. You can have a single REST endpoint that essentially provides that funnel down to the data that Whit was talking about at the beginning, and instead of applying your different configurations at the service level, simply create different versions of the service at the layer level. That sounds a little bit abstract, so let's try to talk through what would that actually mean in practice. Imagine you have a wells data set of oil wells. We take that and turn it into a well service, a one-to-one relationship. The full data is exposed through the service. But I want to provide some people in some set of applications to access to one subset of the data, another set of data, or a subset. In this case, let's say it's the proposed wells I want to provide in a different application, or maybe even just both within the same application itself. But I don't have to publish that as two separate services. I can apply the definition expression within the layer itself. And we can keep going and add as many different variations of these. So these can be things like definition expressions to provide access to subsets of the data, or even just different versions of symbology. You want to stylize your data in slightly different ways. That doesn't mean you have to publish a whole lot of different services. So this can aid your discoverability within the portal itself. Instead of duplicating the same data set in many different ways, simply do one service and then create those individual layers.
Also, I think as ArcGIS Enterprise administrators, a lot of the times, one of the things we worry about is how many services we have, because those services consume a certain number of resources. So if you're an organization that has a large number of services and you're always trying to beef up your server or manage the number of instances so that you're not consuming too many resources, this is a strategy to reduce the number of services you have running an ArcGIS server.
That's a great plug, because what are we doing next? ArcGIS Enterprise 10.7. How many of you went to the What's New session? Shared instances. If you didn't go to the What's New session, I'm not going to spoil the surprise. Just watch the video. It's awesome. Less memory consumption, that's all I'm going to say. I'm really excited about that, but this is not the session for it. We're going to try to round things out. We're right up against our 1 hour limit. I just want to finish off by talking a bit more about those higher level concepts. When you're thinking about what you can do at the layer level, keep in mind all of the very, very cool functionality, the advanced stuff that you can do within the web map itself. Things like smart mapping that you also saw demonstrated on Tuesday and you've seen over the past couple of years is incredibly powerful for getting those different relationships out of your data. Instead of you having to necessarily author every single variation of that within your service, within Pro, you can simply do it at the web map level. The ArcGIS Online and the Enterprise portal has a map viewer that provides a ton of capability here for doing really advanced cartography and really making your data pop. And all of that works at the layer level by applying those styles without you having to do anything different when you published your data to begin with. That's me being 1 minute over and letting Whit power through.
It's okay. We spent a lot of time in the technical details, so we just, as we step out, want to put this back in context. So we used a couple examples in the beginning. Now we can see how those can be applied really quickly. So example one, my content is I need imagery. I need to provide a map with imagery, and I'm drawing weather data on top of that. And my use case is web-based visualization. So my users are going to be accessing this over the web. They're not doing any crazy interaction with it. They just need to see it. So in this case, what we would probably do, we'd use map or raster tiles for the imagery base map. We'd probably use the one that Esri provides. And then for my overlaid data, my weather data, because that's a fairly complex rendering, it's a lot of data, and I have a simple use case, I'm going to use a traditional dynamic map service to make that available. It'll be streaming PNGs back to the client. The other use case, field mapping. I have users within my organization that need to collect utility data with a street base map working offline in my organization. So in this case, it's completely different. For the base map, my street map, I'm going to use a vector tile service because it's much, much smaller. I can take the whole area offline and run it on my mobile device. And for the data that I'm collecting, I'm going to use a feature service so I can do two-way synchronization of that data from my client to the server. So just a couple examples of how those can be applied for different use cases. So as we think about how to do this, what is a strategy for publication? Keep in mind this is all driven by business and IT requirements, so functional and non-functional things. And really, the tools at your disposal are the different types of GIS services, the option to use caching, the option to use generalization, and then different types of styling of those features. These are the tools in your arsenal to actually satisfy these requirements by publishing services and making layers available. And so just if you very process-oriented and you want to think about the process, always start with the business. Make sure you really understand the needs and the use cases and the different types of users as best you can. They will change, but get a good handle on what's needed. Gather those requirements, and then align the technology to meet those. Start with the data. Understand where your data is, how it's being stored, then how it makes sense to publish those as GIS services, and then how to make that available through the geoinformation model using layers, web maps, and scenes. And again, be agile. The technology is changing rapidly in this area, as are the demands of users. So always constantly be reevaluating how you have your data published. So with that, some key takeaways. I don't know, Philip, do you want to take any of these? Or?
Sure. I think the key takeaway here is that good publication strategies really means that you keep that business in mind and then work from the bottom up with what you have available for data, putting it all together, making sure that you consider all the different requirements, including the scalability, the reliability, and the security of the application you're doing. The business first approach really matters. ArcGIS Pro introduced a lot of new functionality. ArcGIS Pro is where we introduced vector tile packages and the ability to create those. It's a game changer. If you have built your own base maps in the past and you have had those days or weeks of rendering, look at vector tile packages. It's just so much better in pretty much every single respect. The only exception being that imagery that you can't use vector tiles for. Focus on what you need to do and then understand the distinction between your services and those layer types. Make sure you can put them all together. And then, like Whit said, this evolves really quickly. Like, upgrade to 10.6.1. It is truly a game changer. You don't need to do a whole lot of other things than that. Maybe you need to update the JavaScript API version that you used in your custom application. Once you do that, all the benefits that you saw for feature layers just come along for the ride. There's nothing more compelling than that for upgrading. Do your homework. Attending this session, you are already one step ahead of the game. This is where we've tried to put a lot of these things together. Make sure you're not just building your applications like it's 2012. Things have changed a lot since then, for the better.
Yeah.
We're a little bit over time.
Yeah.
Thank you so much for coming here this morning. We really appreciate it.